Hey, everybody, I think we're live. I think. So I'm Erin Schnabel. I'm here with Eric D'Andrea. I don't think I've ever said your name out loud. Eric, are you muted?
Yeah, that's right. My video seems to be frozen though. I don't know why.
But did I say your name right?
You did, which
Yes.
is awesome. Yay! I don't know if you can see me clapping.
He's going to help me. We're going to heckle Justin Lee, who is here to talk about Morphia and Mongo and whatever else you want to get into. The intricacies of using NoSQL. I don't know. So that's on the agenda today. We have chat going. As always, please feel free to ask questions. It is our favorite thing since sliced bread. So I really encourage you. Eric, if you need to, Eric is discovering he's in Firefox and not Chrome. So Eric, if you need to drop and come back, that would be okay too. So Justin, do you want to take it away?
Okay. Right. Well, first, thanks for joining, I suppose. So I work on a number of different things on the Quarkus team. One of the things that I spend some time on is the Mongo support, primarily because I used to work at MongoDB. I worked there for almost 4 years. Still a huge fan. So when the Mongo support question came up, 3 years ago, 2.5, it was a while. I'm like, I'll help with that. So that's what I do. And we have a fair bit of interesting support for MongoDB inside Quarkus already. We have the most basic support. We have like injection support for Mongo clients. So you can configure your Mongo connection strings and a few other bits and bobs for the Mongo client injection. So we will create that, manage it for you. We have support for named Mongo clients, which was a new thing for me. I'd never really thought about it, but potentially inside an application, you want to connect to multiple databases, so you can name your Mongo clients and configure each one. So that was kind of cool. Anyway, so we have that, and then we also have Mongo Panache support, which, if you're familiar with the Hibernate JPA Panache support, it basically turns your Mongo entities into active record types or enables repository pattern on top of MongoDB. So that's what we have in general, have had in Quarkus Core. But as more and more people start to use it, of course, there are more and more demands for features, which is great because we all love to see our software get used, right? But more and more of the features were like, well, what about this and what about that? And I could see it. I could see us starting to build yet another framework on top of MongoDB, and it made me a little sad inside because I'm not sure the world needs another one of those when we have existing ones already. And generally, we like to integrate rather than re-implement if we can, right? Well, as it just so happens, I have been working for the better part of 10 years now. I was trying to do the math. It's been a long time, better part of 10 years, working on a project called Morphia, which is exactly that. It is, it's called an object document mapper, an ODM versus an ORM, because there are no
Because you're not in a relational, right?
Exactly. So I happen to be the maintainer of an existing ODM, and I thought, why would we rebuild something when we can just integrate something that already exists? And to my knowledge, now I don't have any numbers to support this. I'm just going based on tweets and mailing list mentions and whatnot. Outside of Spring Data Mongo or whatever it's called, to my knowledge, Morphia is the most popular non-Spring framework on top of MongoDB for the JVM. There are a bunch of others, and I don't want to say, oh, they suck, because some of them are also pretty great. They just don't seem as commonly used. Now, I know there's probably some confirmation bias at play there, but anyways, we needed more Mongo support. I happen to have a Mongo framework, so I thought, perfect. So I started Quarkus Morphia, which is an integration into it. And of course, the wonderful thing about Quarkus is you can use any framework you want with Quarkus, right? As long as you don't care about native image. But as on the Quarkus team, we do care about native image because that's kind of like half our shtick anyways. So my goal with Quarkus Morphia was to provide some of these kind of higher level features that people are asking for on top of MongoDB that is also supported in native mode. So well, I started talking with the team late last year, but I didn't like officially start working on it until like the first of the year. Right. So what we have is, what's the term that we use it in Morphia? Not experimental. There's a label we attach to it that says this works, but it might need some tweaking. Maybe it is experimental.
It is experimental. That's what that one means.
We'll call it that and we'll go with it.
Tech preview is like, well, what?
Pull requests welcome.
No, it works.
Alexi chimes in. Alexi says preview. That's what we call it. Preview.
That's exactly that's the word. I knew experimental seemed a little not derogatory, but like, woo, don't trust that. No, you can absolutely use it today. There's an 0.1 out because that's just, I like to start projects at that low version and just keep working until I decide to call it window. 0.2 is ready, but I can't release it yet. Because even though the code itself works, our testing framework needed an update in order for the integration test to work. So the integration test failed because of some replica set stuff in our testing framework, but it absolutely works. The production code does. I just can't prove it to you on a non-snapshot version. But it works. So so that's where it stands today.
All right, so that's a nice overview of all the things. I'm going to ask some dumb positioning questions.
Lay it on me.
So I think we have had lots of examples. Eric, I know you were on giving your heroes and villains example just was that last week or the week before? Is that last week?
I think it was 3 weeks ago at this point.
Oh my God, please no.
We're getting old.
I have no concept of time. No concept of time. So like with the heroes and villains example, that's a relational data store with JPA. It's a bit more traditional. So why would I use Mongo? Like what are the characteristics that would make me choose a NoSQL database instead of, because Mongo is NoSQL versus relational. You already talked about that it's a document. We'll get to the document part next. So
we'll get to it now because it's actually interesting. So I worked at MongoDB way back in the day, pre-IPO, when to a large extent we were still trying to validate our position in the market, and people were like, "What?" So, and I smiled as you were kind of explaining it because the term NoSQL was a term given to basically everything that didn't have tables. And so NoSQL means something, but it doesn't really mean much because NoSQL encompasses graph databases, key value stores.
It's anything you can't use like select, blah, from, where.
Right. Anything that doesn't use the SQL query language.
Right.
The structured query language.
Whatever it is. SQL is just fine. Let's keep going.
Exactly. So, but Mongo happens to be a particular variant of NoSQL called a document database. And the way that differs is if you have a lot of data that tends to all be fetched at the same time. In a relational database, what you would do is you'd write a query, you join this table, you join that table, you'd left, outer, join, whatever, that table, grab it all together and send it back into one big chunk. So joins can be really expensive.
Yeah, they can.
Right? And so
setting up your indexes and all that stuff to try to make it less expensive is.
And then, of course, not to mention when you delete stuff, do you cascade delete? Do you not? Sometimes it's, anyways. So what a document database does is it denormalizes all that data. So all that 3NF that you spent so many hours in uni studying, you throw it out the window because we're going to denormalize our data. into one giant document, a JSON, essentially JSON. It's BSON, it's JSON in binary form for reasons.
Right.
So it's basically one giant document. So when you go fetch all that stuff, instead of having to join this and join this and join that, and all those IO streams, even if it's internal to the database, you don't do that anymore. You fetch one giant blob, you slurp it out in one operation and send it back. So you're not having to spend all the time doing all the join, creating all this stuff in memory, and then shipping it back. It literally
Right.
just
Now,
goes.
if I can just make sure, so my experience is not with Mongo, it's with CouchDB, which is another document-based data store. So one of the things I might say is that these kinds of document data stores map a little more closely to what you're doing with REST, because you can treat that as
Yes.
a document, or would you describe it differently?
Well, it's a bit of a general statement, and I tend to kind of hesitate to make general statements, but generally speaking, possibly.
It depends. That's the answer. It depends. So
I'm not going to
to
commit if I can make it.
Yeah, there's a question. If I show that,
Uh,
so like if you have process orders, this is one of those questions where in traditional database stuff, you end up, this is where you get the complicated joins and like the transaction table.
That's
versus
actually
your
a
other
really
table.
interesting example, because if you have, and this is grossly simplified, but it's good for demonstration purposes, I suppose. If you have like an order warehouse, you have a list of products and you have a list of prices, right? Now those prices will change over time. So you might want to keep historical prices. So you'd have multiple rows in that table for that particular SKU with a date, maybe a date range and a price, so you can keep historical data, right? Now, when you place an order, you're going to lock that price in for that order because you don't want the price to change once you place it, right? Certainly 4 years down the line, you don't want to go back and see, oh, that price is now the current date and not what we sold it for. So you have a couple of options there. You can create like a copy, you can link to the old price, kind of whatever. So in a document store, what you can actually do is you create your order item that has the user information, the shipping address, all the items in that order as they appeared at that moment. So you'd embed that product with that price in your document. So you just have like one document. It could be massive depending on how big the order is, where it keeps all the historical data in one place. And you can
right, because you're not trying to fit into like multiple tables as records. It's just all one.
And then potentially you wouldn't even need to keep necessarily historical data for those prices, because you wouldn't need it for old orders. You would just move that data from the current product list into the order, which would reflect the price on that day. And then the other store where your products are, they can change willy-nilly because you've frozen in stone the order on that particular date. And it's all embedded in one document.
Right. So the document could
sense.
suit itself more to immutable past record kind of stuff.
Right.
Potentially. All right.
Potentially. That'd be one way to do it, yeah.
Yeah. So now when I was working, my example was really contrived and very strange because it's me. So we had text-based adventure game, because of course. And so what we were using, that's right, game on, because I'm also great at naming things. So I used, so Couch has some different, oh, actually, Jan has a follow-on question. Let's go with him and then we can get back to my example. So he's trying to figure out, like, if I have JPA, or like if I do I mix the two kinds of data stores, or if I'm using Mongo, does everything kind of go with Mongo?
Well, again, that's one of those it depends answers. Generally speaking, anytime you have two different databases, even if they're both relational databases, your application gets very complicated. Now, there can be valid reasons for doing that. And I think generally saying that's a terrible idea is a terrible answer because context matters, right?
Right.
If I were going to use MongoDB in a system, I would probably go all in for that reason. Simply because the complexity consistency, managing data in two places can get complicated. But that said, also used to work at Squarespace, where we used MongoDB, but we also used Elasticsearch, because if you're writing a blog or whatever, you want to be able to search. So we would actually stream data out of MongoDB into Elasticsearch, and we'd use that for searching. And that's whether or not you consider Elasticsearch a database or not. Right. Semantics, I do, because you query it, whatever.
So I'm going to toss this part of the question at Eric, because Eric has been, now this is also my background, but I don't want to talk the whole time because that's not fun. So I'm going to toss it on to Eric. So from a microservices cloud native environment perspective, is this where you would say, like, where you're looking at the order versus the catalog of products? Would your gut say, well, those are two services, and so then the two services could store things however they want?
So I'm going to go with the answer already on the table, that it depends and context matters. I'm gonna cheap out here. So where I stand on this. Aaron and I have had many conversations off camera about different topics and whatnot, and we tend to agree and disagree in different areas. The microservice evangelist in me, like, if you really want to do microservices and take it really down to the low level, that every domain should be split into its own microservice and blah blah blah. But you get large organizations that don't do DevOps very well, and you got to look at holistically across how do they do automation? Are they good at automation? Then you kind of get other factors that play. Say, maybe it makes sense to include more than one domain into different things. We did, at my last company, was a big insurance company. We did have a couple of services where we had some stuff in Oracle, and we were just starting to branch out as I was leaving and putting some stuff into like a Mongo and kind of sharing across domains between data stores, because some things just don't fit well into relational. But the challenge we were having was, how do you keep track or the mapping or the linking between data when like your domain entities are over? You can't see my hands, of course. I'm talking with my hands. But.
I do that too. So you see a lot of frenzy along the sides.
I'm trying to remember. It's right here in front of my face.
Yeah, so like right here. So your domain, so your domain, your entities and your domain context is in one place, and then the stuff you're doing with it in a different place got to be very hard.
Yeah.
So
that's why I would advise against it, but it makes sense in certain contexts.
Especially if you're going against older applications or existing data sources, like maybe you already have a huge catalog in.
Yep. And then before Quarkus and Dev Services, it got really hard to do local development with more than one store, right? Because we all have problems with trying to keep one set of test data up to date, never mind 2 or 3, right?
Yeah.
Yeah. So what I was going to share for comparison purposes, flipping over to my other example, is we were, so the whole point of Game On was to help people experiment with and learn cloud native and microservices. So we created a system whereby you could add your own room, a service that you wrote yourself, and register it, and it would become part of this amorphous, growing, changing map. Very much twisty, windy passages. You'd be going from room to room as a player. But these rooms were all independently provided services. So the Couch database that was CouchDB, that was sort of the center of this, was the map. And the map knew where all of the locations were. So we had, like, every map document had, like, where in the 2D world it actually was in a coordinate sense, the person who registered it, like, so we would know who's allowed to make changes to this room. It had information like connection details and stuff, so that we would know how to put players in the room and some various other things like that. And I used insane, because CouchDB does this, insane map reduce tricks to find neighbors and stuff. Like CouchDB lets me put basically JavaScript queries like in the database, so I can reference them and get selected stuff out. So what I don't know, what I could never figure out is, like, does Mongo do stuff like that? Does Mongo have other strengths? Like, if I'm putting in this example from the example that we have, if I put orders into a MongoDB, like, what kind of stuff can I get back out? Like, let's say I want to can I get a history of price changes based on the orders that are in the system? Or
Yes.
okay, how do I?
Yeah. So
what kind of things can I do that's unique to Mongo?
It's a very long and tortured history. You can do MapReduce inside of MongoDB. Even when I was there, we were telling people, please don't. For reasons, because you could send off a JavaScript function to the database that had your map function, your reduce function, and it would execute these MapReduce, not queries, computations across your collection. And that was sort of fine, but it was executed inside MongoDB, inside the JavaScript engine inside of MongoDB, but it was single-threaded. There were issues around. Yeah, there are a lot of weird, like, corner cases.
Sounds an awful lot like stored procedures.
Kind of actually. But so there's a more advanced way. It's called the aggregation framework, and it seems to be slowly taking over the world in terms of how you access Mongo. So there are two primary ways. There's the query framework with its own kind of query syntax, JSON based. Everything is JSON based, really. But then you also have the aggregation framework, which is a lot more kind of operators you can do on your data. So for your particular case, Aaron, it would probably best be suited as an aggregation framework, because you can select a whole bunch of stuff, or select, not the SQL select. You can query for a whole bunch of stuff, and you can apply operators to it and get a different set. You can totally change the shape of your documents as it works its way down the pipeline, and then apply more operators. We combine it. And the aggregation framework has things like a graph lookup, so you can do like basic graph queries inside MongoDB.
Okay.
It also has,
but this inside is different than the MapReduce inside. So this aggregation framework is
well, the difference is that the aggregation framework is designed so that if you have a sharded server, so you have your data sharded across different systems. The old MapReduce couldn't do that because it would be executed inside the JavaScript engine inside the MongoDB, and it didn't have awareness of the outside world. But the aggregation framework can actually apply across your shards, and the system will distribute those particular calls across your cluster, apply your data, and then gather it back before it streams it back to, well, potentially back to the client. Or you have options. You can either return it like the results of a query, or you can write the results out to a new collection and store them.
So from a microservices process management perspective, is the aggregation layer done in a separate thing so it can go across Mongo instances? Is that how that works?
Yeah, if you want to get down into the weeds, and it's been a while since
I have to get down into the weeds because my brain will fixate on it and I won't be able to think about anything else.
Perfectly fine. So you send off your aggregation request to the primary on a particular server, and since the aggregation framework is cluster aware, it knows it can analyze your aggregation pipeline. It makes an explain plan, which is exactly what it sounds like from the relational world. So knowing what the plan is for this aggregation, it knows that the data is distributed across different shards, and so it can relay those particular aggregation requests to the different nodes in your cluster.
I see. And so
each one
it's like a fork
little bit. Yeah, it's probably more complicated than that potentially, but it's a good way to think about it.
Fan out, fan in.
Fan out, fan in. That's the word. That's what I was just thinking. Yeah. It's been so long since I've had to think about these terms.
We're so bad. God, my brain is rotting. Okay, so that's cool. So, Eric, do you have any other? I can turn this overlay off. Do you have any other questions or observations based on? Because I know you come way more from a JPA world, and we'll look at some code next. But if there's mental maps that we can help people make so that when they look at things, they can anchor it, I think that's useful.
Yeah, I mean, I think you hit it. The key, the big part of it is the distributedness of the data, that it's not all there, and the topology, and that things are topology aware and whatnot.
Yeah. Okay. Yeah, and the biggest. Oh, go ahead.
I was gonna say in my days, you wanted faster Oracle, you added more hardware, right? You added beefier machines and whatnot. You didn't throw it together and scale it horizontally.
Right. And that's still sort of the answer. But I think databases are smarter about that these days, because it can distribute queries and updates across systems. So not everything is doing all the work necessarily. So.
All right. So you want to show some code, and we'll see how Mongo works, and we'll see.
There was one comment I wanted to make before we get into the code. Is I'm a big fan of MongoDB, obviously, but it is a little bit of a paradigm shift in how you model your data.
Right.
So if you're trying to take your data and throw it in a Mongo, it's going to be great, and you have a bunch of different collections where all your data lives, and you're constantly fetching data from different collections to try and put together this structure. It might not be the right choice for you, MongoDB. So getting your head around how to model your data in MongoDB is probably the biggest hurdle that people will face if you're like deeply entrenched in a relational world.
Right. Because in a relational, you are scattered across tables.
Right.
With small, kind of almost smaller units, and then you're doing things.
Your inclination will be to normalize your data. And MongoDB does not operate that way. It's not designed to operate that way. And a lot of people will come to Mongo and try to do that, and Mongo will fall over.
Okay, I have to ask a really dumb question, and maybe someone will thank me, because this is my least favorite word because I don't understand it.
Okay.
The hell is normalizing your data in terms of relational versus not? Like, I don't understand why you still wouldn't need.
Well,
I don't understand.
In general, the idea is that you don't want to duplicate your data, right? You want one place. If you want to update someone's address, you want to go to one place to update it, and then everywhere else will just join that and get the updated information.
So when I think about normalizing data, because I also know, like, from machine learning and all kinds of other data scrubbing and whatever, it just means like make it say the same thing and look the same so you can compare them, which is not what we're saying here. We're talking about like single source of truth.
Right. Well, it's if you think about it, it's the same. It's kind of the same idea. Is like you want that single source of truth. You want that one way to look at your data, and it's because everything links back to the same place in your data. Right?
Got it.
Whereas with Mongo,
foreign key constraints, like I've got tables with foreign keys, and I'm relating by foreign keys and joining on keys. That way, it just works.
And then all your data looks the same regardless, because it's all coming from the same place. Where in Mongo, you're encouraged to just duplicate the world, because the idea is you want to be able to fetch quickly. Now, if you have a bunch of like data that is updated independently, that might not work, because obviously you'd have to update in a bunch of different places, and then your model might not be right, and Mongo might not be right for you. So it's not a panacea. You can't just throw any application at it and it'll just magically scale. You have to think about it.
Right. And well, I would say that maps that duplication of data, which really does bother people who are super used to traditional databases. That notion of duplication of data maps quite closely to cloud native microservice 12-factor ideas, where within this service, which maps to one domain, you do the best thing.
Right.
And if that means duplication of data, that means duplication of data, and you use some other system to map your eventual consistency to eventually get everybody that needs some overlapping chunk, to see the same thing.
Right.
Which is, I think, probably the best way to explain why the two systems, I feel like they sort of exploded at the same time. Like, I feel like Mongo and CouchDB and all those kind of really took off right when cloud native and microservices started.
Well, microservices are about scaling the server infrastructure, right? And MongoDB was about scaling the data infrastructure.
Yes, but I think the emphasis that came with microservices, where you have the service that's much more focused on doing one thing and doing it well and focusing on one piece of the data rather than having a unifying whole organization schema that limits any one piece's ability to evolve, made room.
Yeah. It's definitely an interesting coincidental rise for sure. I hadn't really thought about it, but you're about right. I like to tell people that. So I worked at Squarespace and I went to Mongo, and when I went to Mongo, microservices were not a thing. We were still all Java EE and application servers and whatnot. And so I went to MongoDB and I worked on database drivers in Morphia, Hadoop stuff. And then when I left Mongo and I came again to like the wider world, like everyone's like microservices and REST and it's like, what happened? I went underground for almost 4 years, and I came back and like everything changed. Yeah.
All right. So let's look at some code, and please ask any more questions.
Yeah. Like I don't have a whole lot formally prepared because I like to respond to questions. So if you have them, throw them in the thing, and Aaron will tell me. But my code's over here, so I'm not going to see your question.
No, it's great. We'll know when you're looking at code, and you'll know when you're talking to us. It's fine.
Okay. So is my code on the screen? It all looks the same.
Not yet. You have to share your screen again, and then I have to turn it on.
Again? All right.
Yeah.
Fine.
Yeah, I think you stopped sharing at some point.
Oh, that was the button I pushed.
There you go.
I hit enter, and it just happened to be focusing the stop sharing button, and it just vanished on me. Okay, sorry. Okay, so the comparison I like to make for Morphia is if you're coming from a relational world, you've almost certainly used Hibernate or JPA. So I like to describe Morphia as basically Hibernate, but for Mongo, to give it some context. And a lot of the concepts are very similar. I'm going to close this terminal because we don't need it at the moment.
Yeah.
So what I'm looking at are just the integration tests for the Quarkus Morphia project, because it's already up online, and if people want to go look at it, they can look at it and run it and play with it and see it, everything. So in this case, we have a book. It's a very basic example. So we have a book, we have some fields. I'm not sure how well that shows up. We have an ID, we have a title, we have a date that's published, and we have, in this case, we have a single author, and we'll go through some of the details. And so you just define your normal POJO like you would with Hibernate or anything else. And then for Morphia's sake, you have to give it this annotation entity. And just like in Hibernate, it basically tells Morphia, like, we want to persist this particular type.
As a unit. This is
as a unit, right. So in this case, so we have this entity book, and we're going to store it in the collection called books. Actually, I'll have to run this. No, because we use containers, so none of the data is going to be there. That's unfortunate. Because we don't use local MongoDBs. It doesn't matter. So anyways, and that's all it takes. And now if I want to save it, I can instead of an entity manager from JPA, Morphia has a data store. So we just tell the data store, save this book. It knows how to map it, and it'll save it and it'll load it. So there's a few things here. I don't want to get too far into it. We'll come back to those. Scroll them out of the way. So Morphia requires an ID field. Every document has to have an ID.
Right.
Not entirely different from a table in Postgres. And this annotation just tells it this particular field is the ID. Now in Mongo, if you save a document to a collection, you don't give it an ID field. It'll be _ID in your document. If you don't have that, Mongo will just create one and it'll sign it. And it'll be dynamically generated object ID. And if that's what you want, that's fine. Morphia,
CouchDB is the same.
Right. Morphia requires an ID field because for top level entities, we'll call them. Because
why? Since you wrote it, how come?
You can't. To be able to query them, for one, like you want to go grab one by ID. Otherwise, I mean, you could like query like I want this book that has this cover of title, cover of the binding has this title, this author. You'd have to query by other attributes, and you can do that, but ID is required for the top level stuff for historical.
And that object ID Go ahead, Eric.
I would say I find over time too, the ID almost becomes less important from a domain perspective, right? Like whether it's a sequence, and I know here it's probably more of like a GUID type thing and not a sequence, right? So it's only really there to, hey, if I want to update the thing at some point in time, I need this. But otherwise, the stuff that's in the collection is more, I'm looking at it from different slices, if that makes sense.
Right. Fetching by ID is always going to be faster than a general query. It's automatically indexed. You can index the other fields too and make them reasonably fast. But
so is the object ID object, is that a Morphia thing, or is that a...
That's a Mongo Java driver thing. There's a standard...
That's all I needed to know. That's a Mongo provided thing, not a Morphia.
It's a BSON type, essentially.
Great, okay.
And that'll mean something to some and not much to others. But so we'll come back to some other bits. But as you can see, it's a standard object. There's nothing terribly fancy about it other than the annotations. Now, there are a few features in Mongo that Morphia supports. So we're going to start with the indexes. Because in what distinguishes, this might be out of date, what distinguishes MongoDB from, say, Couch, because Couch is key value. You have that key, you go get that particular value. Mongo supports secondary indexes, so you can query against non-ID, non-key values inside the data store. So if you wanted to query against the title of the book, for example, you don't have to index it, but you'd be silly not to, right? So in this case, in this line here on line 20, we're defining multiple indexes potentially, but in this case, just the one. So we have an index against the title field, and it's a text index. So Mongo supports this particular type of index is a text query. So it's a little bit fancier than just like, does this string match? There's stemming.
Does it do like built-in fuzzy matching kind of stuff, or
it can potentially. You can do. There's a whole document on it. So text searching, it'll do stemming. So you can compare against like the roots of words so that they're sort of the same but sort of not. It can also distinguish between French versus English versus German.
Oh, that's pretty cool.
The whole text indexing thing is rather complicated, but you
it
can
always is.
So in this case, like when I mentioned that Squarespace, we were streaming out to Elasticsearch to do searches with this text index, which didn't exist at that time. We wouldn't need to do that because we could just do the query directly inside MongoDB. So we wouldn't have to have that duplication of data and updating.
So I don't remember. So it's been a while since I've actually looked at my map service, but the map service for CouchDB, I think CouchDB has the notion of a view, which is basically the same as an index. So it's not key value, it's document based, but you can make views that are similar to this index. A view is an index, basically.
Right.
So you can combine multiple fields to say, I want to be able to query or find documents referencing, in my case for map, it was always like 2 or 3 different fields because I was looking for XY coordinates and neighbors, and so my views were a little different, but there is a similar concept there.
Well, yes, sort of. In general, in Mongo, you can query against any attribute of any document you want, because that's how Mongo functions. You define indexes to speed up those queries, of course.
Right.
But Mongo also supports now, as of 5.0, 4.0, somewhere along, they introduced a view, which is like a relational view. You can kind of create like an ephemeral view over a particular data set that may not necessarily reflect how the data is stored on disk, but it looks that way. So you can query against that way. And they have realized and non-realized views as well inside Mongo. So both is the answer there. It does have views, but they're different. But you can query against any attribute you want. Generally speaking.
Yeah, I love how we're running out of nouns, so everybody uses kind of the same nouns to mean something a little different.
Yeah.
Okay, so if I skip
a little overloading
to some JPA stuff that I only half know because I'm really bad at it. So Eric could be like, "Oh, Aaron, you're totally wrong," which is also fine. that reference thing on line 27, is that kind of how we get to many to one, one to many, how you don't nest
Yes.
things, bad recursive stuff?
Yes. So you can do references inside MongoDB. It's not necessarily encouraged because it breaks that document model, but any good system needs like a pressure relief valve. Sometimes you just have to do it, right? Even though it's not necessarily ideal. So MongoDB has a thing called a DB ref, which is an ID, a collection, and potentially a database. And it's stored in the database as a DB ref. And it's basically that tuple or the triple, depending on how you define it. Morphia makes that transparent, such that you can just treat it as if it were part of the thing. So there's a couple of options on this. In this case, how it's stored can be expensive. The DB ref is its own kind of BSON type that can take up a bunch of space. And sometimes if they're always in the same collection, for example, it makes no sense to also store the collection name for every single reference into the database. So this ID only basically says in this field for the book document, we're only going to store the author ID because we know that all the authors live in the author's collection. So there's no point in storing that information over and over and over again.
Right.
Now, of course, the problem with having a reference is it basically is it's an implicit join, but it's done in two different fetches in the Mongo world because of how Mongo works. So every reference that you get, once you pull back the book object, it's going to go then fetch that reference object,
which is
author.
the same as a lazy load of a JPA many to one
right,
to many.
Yeah, because a lazy reference isn't a join. It's they proxy it and fetch it after the fact, as opposed to an eager join or an eager reference, which would be fetched as part of the join.
Right.
I think too, doesn't Hibernate have something where it will only fetch it if you ask for it? Like if your actual object model traverses it. So like marshalling or something like
Isn't
that.
that the lazy? That's
the lazy versus
Yeah.
eager. So if it's lazy, it'll wait until you touch it and then it'll go get it.
Right. So by default, for historical reasons, references are eager inside Morphia, and that is true. That was true when I took over the Morphia projects. I think the smarter default would have been to be lazy, but I didn't get to make that choice. And now fixing it would break old code.
Well, Felix likes this plan. He says he didn't know about the ID only thing yet. So you've already taught somebody something, and that's cool.
Oh, fantastic. But you can say that they're lazy instead. So, and in that case, I do proxy them so that they're only fetched if you refer to them. And this can be great for performance things where sometimes you need it, but sometimes you don't. Make it lazy, and if you need it, it'll go fetch them. And it is there's still some optimization left to be done. If you have if you had like 4 different fields and they're all references, each one of those will be a different fetch to the database because every time you dereference that particular field, the proxy triggers and goes and fetches. However, if you have like a list of authors, because a book, I mean, let's be honest, a lot of books have multiple authors, right? So you'd want to be able to store more than one author. So in this case, if it's a list of authors, all of those referenced authors are done in one fetch. Right. So it's one query. Here's a list of IDs. Go fetch me those authors, and then fetch them all in one database query. So it can optimize things like that. But if you have a bunch of individual references, it can't. Because it would make much sense that way. But yeah, so you can have references, maps. You can have references of lists, maps, and sets, or the 3 primary collection types. Maps are less common in a model because it starts getting weird, but I support them because I try to be as complete as I can. So that's a reference. 1 second, I need to close that.
What's the difference between you've got the indexes declared at the top, but then you've also got a field that's annotated with indexed?
I was about to mention that. So generally, there's my mouse. This is the primary way of doing an index, right? You want to up top where it's kind of visible. But if you just want to index a specific field, you can just say @indexed, and it has some options as well. This syntax up here looks a little bit cumbersome, and it sort of is, but it was done basically to unify how this syntax is done, so that it all shares common code. But you have a bunch of options. Options equal index options, and then you can define a whole bunch of things. So while we're looking at it, I don't know how small that comes up on the screen. Fonts are weird. But you can do a couple of things. There's a number of options when you're defining an index. If you wanted to, like I mentioned, you can do the text indexing with languages. You can give it index a name if you want. Mongo will default an index name to basically the fields that are indexed and what sort order they are. So the name can look really weird. If you don't care about the name, and generally people don't, but your DBA and DevOps types might. So you might specify a specific name to give it some sort of semantic meaning. So when you're looking at the database, you can tell what's what. And there's a couple of options. One of the interesting things is you can do a partial filter in Mongo, so you can index only part of your documents. So create this index, but only for the documents where this particular filter matches. So it has these fields, or it doesn't have those fields, or whatever it happen to be.
Right.
So
yeah, that feels very much like a CouchDB view, because
right.
you're basically saying I have a view of documents that I can reference that are this subset of fields, and I can query against that view.
Right. Yeah, because Mongo will index every single document. So even if it doesn't have that particular field, it'll create an index entry for that document where that value is. I don't know what it would look like internally, but you can filter out those fields because you can filter out those documents for that index, because if you're indexing by
right,
whatever, you don't want an index entry if you're never going to query for that particular.
Yep, document. That makes sense.
Whatever.
That makes sense. Cool.
One of my favorites is this expire after seconds. It's a TTL index. So if you have like a cache, for example, so what we would do in Squarespace is we would generate a web page on first request, and we'd stuff it into a cache. And in our case, we used Couch actually for that cache. But you could, in theory, generate the entire HTML, stuff it into a collection, and then dispatch that HTML every time you request it. And then you can use the TTL to remove those documents. If it hasn't been fetched after an hour, delete it. We're done with it.
Yeah, that's kind of nice.
Auto prune things. It's kind of nice. So yeah, so that is that's a basic entity. One of the newer features I haven't used a whole lot, but it exists, is document validation. One of the strengths of MongoDB that make it so nice to get up and going is that you can stuff whatever data you want into it, and it just goes. And so early on when you're working, it's nice because you can just evolve your model and no one cares, right? Mongo doesn't care. It'll take whatever you give it and it'll send back whatever you want, whatever it has, right? That's the dynamic schema. That is the term that's used now. It's not schema-less, because there's always a schema, even if it's implicit. But eventually you might want to start imposing certain constraints, especially if you're doing multiple teams. Like this team is working in Java, but that team over there is working in Ruby. There's a C# team, and you're all working on the same database. It can be complicated because every Morphia stores it one way. The C# driver has its own kind of nomenclature for how to track things and how things are stored or named or whatever. But you want to be able to unify that to make sure that no one's trampling everyone's data. So you can use document validation to validate that the documents that you're storing have a certain shape to them, so that you're not destroying data, renaming fields or what have you. So you can define this validation to make sure at the database level that your document meets certain criteria before it gets saved.
I think you mentioned something that we could have a whole separate conversation about another time, and that was sharing a database across different applications. My ears went ding.
Yeah, exactly. It gets very complicated. When I worked on the driver team, I was on the Java driver team. There was the C# team that worked with us because the languages are so similar, whatever. But, I sat next to the PHP driver dev and the Perl driver dev. We all had these different nomenclatures and different processes for how to do
Right, because you have to
things.
integrate with the language semantics, which are different.
Right. And it gets very complicated very quickly because everyone has their own view of how things should work based on the language that they worked in, because this is how, PHP has its view of this is what a document should look like because this is how PHP people think. And at some point, you're going to need to unify that if you're all talking to the same collections in the database.
Right. And I think that's where Eric's like, ooh, so, theoretically speaking, people shouldn't do that. But, there's theory and then there's what happens.
Right.
That's why I said it's a whole separate conversation. I didn't want to say, no, don't do it.
So there is one other thing I wanted to look at before we get, because we only have a few minutes left. So I talked about this entity and I made the reference of a top level entity,
Right.
Which I don't know if anyone caught, but there is a distinction here. Because remember I told you, you denormalize your data and you duplicate it and store it everywhere. So if this were an order item, for example, and
Which we talked about, right?
Which we talked about, but let's just assume rather than having authors off in its own collection, we want to store them as part of the book. So you can actually do this, and you'll see that author is no longer a reference. It is actually just a field on the object. And so what will happen is rather than having the ID stored on the on the book document, it'll say, you have your book, and it'll say author : and then some object ID string. It'll actually have a whole other document embedded in the book document. So we're basically duplicating the author information inside the book. And this is what's known as an embedded object in Morphia nomenclature. So if we look at author,
Eric confirmed for me because I know crap about this, but I'm pretty sure you can do a similar, it's not how it's represented in the data at all, but if you're going through the panache layer to JPA, you can, there is a embedded.
In JPA itself, you can do this, and it's all in the mapping. Like the data structure itself doesn't look like the mapper does. It's just the mapping layer.
Right.
So if you would ask me what annotation is it off the top of my head, I'd have to go look it up.
I forget what it is either.
It's been too long.
Yeah, but so in this case, it's a similar embedding in terms of like how I would interact with it programmatically within my application. But the implication from Mongo is that the data actually is replicated in the final binary JSON structure in the data store.
Correct. Yeah. So the difference would be, it would be like a whole set of new columns at the end of your book table for the author information.
Right.
Was how it would look in a relational. But in this case, it's just, instead of a field ID, it's a field and a whole new JSON document underneath it.
Right.
Which then you can query against. You can query against, go find me all the books that have this author name, because the author is part of the book at that point.
Right.
And if you had, if you go back to the book, if you had a list of authors, again, like we had earlier, then author would be an array field in your document, and it'd be an array of documents inside your.
Right.
And now this is a bit more powerful than the relational world, because if you tried to have an arbitrary number of authors tacked onto a book, you would have to do a join table. There's just no way to do it, because you can't have an arbitrary
and it would be the many-to-one relationship and all that stuff. So I have one, when you do the embedded document in that way, does each author in that case have its own ID, or is it more like a nested object where it just has the fields?
It would just have the fields. You could, the way this is modeled, because I'm tinkering with it, the way this is modeled, there is an ID field, but it wouldn't necessarily have to have one.
Right, because it would just be like embedded attributes, and you would just know what those attributes are because you have the structure. And this would be a case where if I'm going to embed it, oh, okay. So if I have the embedded object, can I use like validation on this? Like, is this sub object? Can I do validation on this to make sure that
validation applies at the collection level? So you'd have
so it's only
in your validation rules, you'd have to say, author dot whatever, and you'd have to reference from the root of the book down into the author because it would just be
That's
part
kind of a bummer that I can't put it like here.
A little bit.
Okay.
In theory, Morphia could work around that, but it gets complicated in terms of how to build those validation structures. I'm not sure I want to.
It's fine.
But
I'm just
we do it
curious.
for a couple of cases.
I'm just trying to connect.
So one thing I want to get to, because I realized that we haven't talked about it yet, is this is a Quarkus Morphia talk. So how do we make this work in Quarkus before we run out of time? It's pretty straightforward. It is a plugin, or it is a module. So if you look at the POM, you just have to add that dependency to your POM. And what will happen is that Quarkus will go through, it'll find all your entities, it'll automatically register them for reflection, so that if you want to go to native mode, that works. So far, everything I've run in native mode works with Morphia, and that's the goal, is it to be 100% native supported. Yeah, and so I don't even, there's nothing. It's
right.
pretty
You wouldn't
standard.
need the version thing. That's a project because you're building an integration test.
Right. Yeah. So
You
if
don't
you're
need that
building your own, you'd be using the BOM, and you'd have dependency management set up for you.
Okay.
And that's really all there is to it. You add that particular dependency, you'll get Morphia as a transitive dependency, and then it just kind of works.
So can you show me like where a REST client is, so we can see the bridge between Morphia and Jackson?
Yeah, so if this is our REST endpoint, so as you can see here, we're injecting the data store. This is the default data store that you would get. You can also inject particular configured Mongo
that's what you
client
said.
data
You
source.
had named one.
So this would be an entirely different data store that talks to a different database as configured by this. And that configuration looks like this. So inside, this is our default data store configuration. The create caps is the test feature that doesn't work in the integration test, because it requires a replica set, and our flat doodle that we use doesn't do, it configures it strangely and it fails for reasons in native mode. The indexes and the validations are not created by default. You have to explicitly tell them to create the indexes and the validators if you want them. If you don't want them, you just leave them out. You tell Morphia which models to go package up.
Right.
If you're using Morphia directly, you get the mapper object, and you would say mapper.map package, and you'd give it, or you'd say mapper.map and give it a class name. And if for Quarkus Morphia, you just give it a package or a comma delimited list of packages, and it'll go out and find those for you and register for them. So when you get your data store, you're all set. There's no mapping to be done. It's all pre-made.
Right. Okay, so quick aside, if I was going to integrate this with dev services, I would be able like create indexes, create validators that would all work with test profile or dev profile to change
all that
behavior during dev
configuration
services.
should work, because it's standard Morphia configuration. Dev services gets a little different, because dev services is keyed off the Mongo client stuff, and I have not tested it with different dev services, but it should work. I have specified a connection string so it doesn't use dev services.
Got it. Yep.
So I guess
I was more tripping over like when you're using dev services with Postgres, H2, whatever.
Right.
Sometimes you fuss with whether or not you're going to do import SQL or and those are profile triggered sometimes.
Right. Yeah,
So
all that should work here, because it's the standard Quarkus microprofile config.
Okay, so if we flip back over to the resource then, where you have your REST client. So we have the usual Jackson working on responses for JSON, right?
Yep.
So Jackson is pulling in the book, mapping it to our class of book that we looked at earlier. And it's interacting with the data store to...
Yep.
Now here you have save as the author.
This
is Morphia then doing something where it recognizes that reference ID?
Sort of. One of the requirements of Morphia at the moment is, in order to reference an entity from another entity, that reference has to already have an ID generated. Morphia will not automatically save referenced entities. So in this case, we're saving the author first so that the author gets assigned an ID, because Morphia / the driver will assign an ID for you on the ID field.
Oh, this is an inbound post. So
Right.
I'm sending in a book that has an author, which will, how does that work? If I post a book that has the author, presumably what the client had is just the author name and stuff. Like, how does it know? Oh, look
It
at
looks
you
like
with your
this.
Robert Jordan.
So, yeah. I was in the middle of a reread, and it doesn't.
Yep, I know.
So we create a new book, and then we assign the author of the book with Robert Jordan. So it's a brand new, unpersisted book, and we post it. So there's no IDs assigned. Morphia has never seen this before. So when it gets here, the first thing it does is it saves the author. And what that process will do is it will see that author does not have an ID value yet, and it's an object ID, so it will just generate one for you, because you don't really care what the ID value is.
Now I understand that this is just the app you wrote. So
yeah.
But so in usual case, what I might do instead is get the author field from the book and see if one exists that has the same name, and get that first.
Right.
Okay.
Yeah. Yeah. In general, of course, you don't want to create a new author every time, but you can look up, go find the Robert Jordan. Here's a new book he wrote. Assign the author to save the book.
So now,
but in that case, you'd already have an author. You would have fetched author from the database, so it would have an ID already, and you could just save book.
From the client side, they would have okay. So what you're saying is a usual workflow is.
Well, it depends on how you design your REST API, right?
That's what I'm trying to figure out. I'm like, how would I get to the place?
You could find.
I have to.
You could do it where you pass in the book, and the server side was smart enough to go look and see if that author already exists somewhere, and if so, fetch it and attach it to the top level book.
Right. That's what I'm trying to figure out, because then if you still have that book with the author as just the reference ID, I have to find the author to have the reference ID to save it that way. That's what I'm trying to figure out. If somebody posts a book, it's going to have the fields, not the reference ID. So I'm confused about how I fix that.
So you could do this, for example, you post a book, you go find me the author named Robert Jordan, and now I have the author, and then I can say book.author is equal to author.
Right. And so then when you saved that book, that modified book,
do it this way.
It would, you turned it into a list. That's why it's mad at you.
Right. Yeah, exactly.
So then when you save, if you did it that way, then when you save it with the old one where you were just saving the reference ID, because you looked up the author first, it can get the reference ID and just save the reference ID. Okay.
Right.
Sorry. I don't know if that matters to anybody in chat, but I was trying to figure out how that
it's just that workflow is weird because it's just an artifact of the integration test.
Yep. Oh, I understood.
That's it. Yeah. So yeah, that's essentially all there is to it. We could talk kind of Morphia all day, but then it all builds to native. You can run it as a native application, and everything works. What's left to do? I don't have aggregation framework test in here yet. There might be some work left to do on that because aggregation stuff is complicated internally. But that's next on my list. And also there have been, I need to look at Panache and see if there's some way to get Mongo Panache working on top of Morphia without binding the two together. Because I don't want to pollute Morphia with Mongo Panache stuff, but I can imagine there are folks who would like to use Mongo Panache on top of Morphia potentially. But we'll see. Aggregation will come first because that's the obvious fix. The Mongo Panache stuff, people may or may not want that. I don't know yet.
Yeah. All right. So we are actually past the hour. I knew we were going to go super long and have no problems. So I hope a lot of people learned something. I learned some things. I hope this was useful. Thank you, Eric, for joining and helping me pepper Justin with lots of fun questions. And
Yeah, no
Justin,
problem.
thank you so much for coming and showing all the Morphia stuff. If you guys want to go try that out, you saw it was a Quarkiverse extension.
Yep.
And I think that's pretty simple to do. Do you have any last words, either of you?
I'm on Zulip. There's GitHub issues for Quarkus Morphia and for Morphia. We're trying out a Discord chat. I had some Morphia users like, we should really use Discord. So we're giving it a shot. We'll see. It's not terribly active yet, but if people want to use it, then we're there. But yeah, if you have questions, feel free to ask. I'm always happy to answer questions. And if there's something missing that you tried and it didn't work, then sure, let me know. And I'll try and get that fixed. Hopefully, once this next version of Quarkus comes out, 2.8, I think is where the fix comes in, I can start doing a lot more in terms of integration feature support.
Cool. All right. Well, I think we're going to wrap up. Thank you, everybody, for watching, and have a happy Monday.
Thanks, everyone.